Hello, Pascal.
Hi.
Hey,
Good
how are you?
afternoon.
Good to have you back.
Ready.
Code Camp.
Thank you very much.
So I don't see you at this moment.
Shall I start my video now?
Yeah, absolutely, absolutely. Please go ahead. Because I've got some questions for you. No tricky questions, I promise. So the first one is, do you see my screen?
I don't see your screen anymore.
Okay, because you shared it, but not a problem. But can you see my background TV?
Yes.
Okay, and do you maybe recognize anything familiar there?
I'm sorry, it is too small now for me.
It's too small. What's one of your favorite songs? What's your muse?
Yes, yeah, absolutely. Muse. I love Muse.
Okay.
And not almost all songs, but Starlight is one of my favorites.
That's great. So people also know you as a community guy. I know you're preparing something.
Yes, indeed. I'm organizing the Dutch Azure meetup together with two other guys, and we are also, indeed, what you are showing now, organizing Azure Fest. And we started that last year, and we are in doubt because of all the regulations about Corona if we are going to continue it this year, but otherwise we will do it next year. So we are in doubt now at this moment about Azure Fest.
Okay, okay, I understand. I've read an interesting fact on your personal page or on your company's page about the fact that one of the things that make you happy is solving complex functional or business problems with very simple technical solutions.
Yes.
Is there such a thing?
I believe it is. There is, yes. And that's what I love. I really like simple solutions that people can understand and which is maintainable for future, for other project members in the future. So that's what I really like.
Yeah. Excellent. I was mentioning before that Kubernetes is the rock star of this day,
yeah.
This Code Camp day. Why is that?
Yeah, Kubernetes is really hot. If you're running containers, then you have almost no other choice than using Kubernetes for your workloads. So yeah, also during this session, I will explain what the advantages are, what the powerful things Kubernetes has to offer. And yeah, I think it's great, but let's see that during the session.
Okay, okay, then let's do that. So you can start whenever you're ready.
All right. Then I'm going to share my screen, start the presentation. So, well, thank you for the introduction, Florian. And I'm sorry, this is still, all right. So yeah, good afternoon, everybody. Thank you for taking the time to join this session. And well, during this session, I'm going to explain what is so powerful about Kubernetes to use it in practice. So this is let's say, introduction session to Kubernetes. And if you talk about Kubernetes, we are also talking about Docker. And that's because Kubernetes is running Docker containers. But it is not an introduction into Docker. So hopefully you have some knowledge about Docker. And although it is not an introduction to Docker this session, I do want to tell you why I like Docker containers. So one of the first things that really is remarkable is how fast the Docker containers are. So your application is in the Docker container, you start it, and it is really fast. It is during startup time fast, it is runtime fast. And also during this session, you will see how fast it is. Docker containers are also portable, which means I can have a Docker container running on my laptop, for example, and I can just, you can run it on your laptop as well, or in development environment, and finally in production environment. So that's really handy. And last, Docker containers are isolated, which means that everything that I need to run my application is within the Docker container. I don't need to install the .NET framework or Java. I don't need to install SDKs or other libraries. Everything is in it. So that makes it really nice. And maybe you haven't touched containers yet, but if you take a look at Gartner, they have told just 2 months ago that by 2022, which of course only 2 years from now, 75% of the global organizations will be running containerized applications in production. So that is massive. And if you want to run containers in production, you have some challenges. So challenges regarding scaling, load balancing, and fault tolerance. So to explain what the problems are without an orchestrator, I'm going to explain that during this sample. And during this session, I will be using a very simple sample solution, a demo solution, and it has a front end and a back end. I can host that on a server, no problem. But what if my application is a success? And of course, it is a success. Then I want to scale out. So let's say you want to scale out the front end. And then I need a load balancer because now the traffic needs to be routed to the other containers as well. Only scaling the front end doesn't make any sense. So let's scale out the back end as well. You need a load balancer there, of course, as well. So this can run perfectly fine. I have to do a lot more. I have to maintain the load balancers, but there will be a day that I reach the limits of this server. So what I actually would like is to use multiple servers. And then each server should run a part of the whole workload. And now I have to maintain even more. So this is where a container orchestrator comes in. It can help you with this. It can manage it. It can do the functionality of the load balancers, for example. And also, a very powerful feature is when one of the servers goes down, the container orchestrator will notice this, and it will be running the workloads on the other servers that are left. I'm not talking about Kubernetes yet. I'm talking about container orchestrators, and there are a lot of container orchestrators. A couple of years ago, there was this container orchestrator war, and there is only one winner actually left, and that is Kubernetes. So we don't have to talk about the other container orchestrators anymore. OpenShift is, by the way, based on Kubernetes, so that could be still an option. How hot is Kubernetes really? Well, if you take a look at the Google trend, so where people are searching for Kubernetes, if you compare that with the other orchestrators, yeah, you can see it is really hot. This is from the last 3 years, and as you can see, only in December, the people are not searching for Kubernetes anymore, I guess because of holidays. So let's dive in a bit. How do orchestrators look like? Well, from a high perspective, they exist about multiple servers. So it's a cluster of machines. Some machines are master machines, some are worker nodes. The worker nodes are running your containers. And for Kubernetes, there is no difference. So it looks exactly the same. Sometimes you read an old article, you read a book about Kubernetes, and they are talking about minions. When they talk about minions, they mean the worker nodes. It's the old terminology. Sometimes you still see it. If we go one step deeper in the architecture, we can still see the master and the worker nodes here. And a cluster can consist of multiple masters and of course multiple worker nodes. If you take a look at the master, there are a couple of components which are important. First, the controller manager that contains some controllers that are needed for Kubernetes itself. Then there is this etcd database. It's a key value open source database that Kubernetes is using to store all its information. The API server is your access point to manage Kubernetes. You can manage Kubernetes using the command line interface. It's a tool that you have to install called kubectl. Some people call it kubectl. If you don't like CLIs much, there is also a dashboard, a web interface. That's also communicating with the API server. The API server is a REST-based server, so you can talk to the API server using any REST-based client. For example, there is a nice add-in for Visual Studio Code, and Visual Studio Code is also talking to the API server. Then there is a scheduler on the master. The scheduler is responsible to schedule workloads on a worker node that has enough resources available and is healthy. Let's move to the worker node. I'm sorry. I thought I closed this stuff. The worker node has the kubeproxy. The kubeproxy is a load balancer and reverse proxy. So all traffic goes through this kubeproxy and it will be routed to the containers. The kubelet. The kubelet is responsible for the health of the containers, the pods, as you can see there, but also the health of the worker node itself. And then you see that term, pod. And if you are pretty new to Kubernetes, then you have maybe heard that term a lot, a pod. What is a pod? So as you can see, a pod can at least contain one or more containers. And I will go into detail after a couple of slides. So I come back to this. Let's first talk about the history of Kubernetes. It all started at Google. Google is using container technology for over a decade, and they are using an internal created system called Borg. A group of people in 2014 started a new project because they found Borg too complex. So they created a new project called 7 of 9, the friendlier Borg. If we go to 2015, July, then Kubernetes went version 1. And with this version 1, Kubernetes, Google gave the source code to the open source community. Together with the Linux Foundation, they created a new foundation, the Cloud Native Computing Foundation, CNCF. Kubernetes was the first project of CNCF. And in the meantime, there are a lot of projects, I guess more than 40. Each project in CNCF has a certain level, how mature the project is. And well, it will be no surprise for you, but Kubernetes was the first project that reaches the highest level, the graduate level. In the meantime, there are multiple projects with this level. Nice to know. The 7 spokes in the logo of Kubernetes is still a nod to the codename 7 of 9. So if you talk about Kubernetes, you see the abbreviation K8S a lot. And the 8 is just standing for the number of characters between the K and the S. There are 8 characters in between. It's an open source project. You can find it on GitHub. It's one of the most active projects on GitHub. And Kubernetes is written in Go, in the Golang, the language from Google. Kubernetes is known for its extensibility. So every component in Kubernetes is extensible or replaceable. And that is very powerful. That's also the reason of the next point, that there is a really big, large ecosystem. And it is growing and growing. And for me, that is a big advantage because it can make my life easier with maintaining Kubernetes or creating projects for your customers or for your own company. So what we will also see, also during this session, is that Kubernetes can be configured on a declarative way. That means it is the opposite of imperative. And with imperative, you say exactly what a program has to do. So with declarative, you just tell what he has to do. And he finds out itself how to do that. This can be done using YAML files, just text files. You can add them to your Git repo, apply CI/CD to it, and you have infrastructure as code. Another important fact of Kubernetes is that it is running everywhere. So you can run Kubernetes on your own laptop using, for example, Minikube. But you can also just use Docker Desktop for Windows or for Mac. Just enable the checkbox and you have Kubernetes running. It even runs on the Raspberry Pi. People love to create clusters with Raspberry Pis running Kubernetes. It runs in your own private data center. And of course, the public clouds are offering Kubernetes as well. The first one who offered it was the Google Cloud since 2015. In 2016, Microsoft Azure came out with Azure Container Services. They were working on a new solution, AKS, Azure Kubernetes Service, and just a week before that, Amazon came out with EKS. So, well, I'm a Microsoft Azure MVP, and I used to work a lot with AKS, with a lot of customers that I'm having. I'm a consultant, so I visit a lot of mainly big enterprises. I'm not going into detail about the differences between all the public clouds and what they are offering, but there are differences, but there are also similarities. For example, which is similar is that all the masters are managed. That's a lot of work to do, so it's very nice to run Kubernetes in the public cloud because then that is done for you. All the workers are just virtual machines in all three clouds. And upgrades are managed for you. So normally, if you host Kubernetes in your local data center, you have to do a lot more than in the public clouds. There are also some differences, so you can keep an eye on that if you are choosing a public cloud to run Kubernetes. For example, patching is being done different. And the pricing is also different, of course. For example, at AWS, you have to pay for your masters. And at Google and at Microsoft Azure, you are not paying for the masters. So that's a big price difference. Well, as I told you, I'm a Microsoft Azure MVP, and I have a lot of knowledge about AKS, not about the other Kubernetes services from the other cloud providers. So a little bit more information about AKS. And you can see a cluster here, a Kubernetes cluster, which consists of 3 masters, which is the default. And in this case, 3 workers. That's what I decide. And the masters are managed for you at Microsoft. And you don't pay anything for those virtual machines. You just get it. You also don't pay for the Kubernetes service itself. It's free. You do pay for the virtual machines, which are the worker nodes. And the price depends on which virtual machine you choose. You can choose any virtual machine from around €5 to hundreds of euros. It depends on, do you want an SSD hard disk? How much memory do you want? How fast should the CPU be? That kind of things. So let's move to production. And therefore we need a Kubernetes cluster. On Azure, you can create a cluster several ways. You can use Ansible, Terraform, the portal. I'm just showing it here with the CLI. So you can create a cluster like this, create a resource group and create a cluster, and you will end up with a cluster. Very nice. In enterprise scenarios, you have a lot of options, and we are not going into detail because there are a lot of options. So there are many, many possibilities. So I have provisioned a cluster already on Azure. And from now on, during this session, we are going to talk about the concepts of Kubernetes. Because I think that is very important, because Kubernetes, well, also has a disadvantage, of course. Kubernetes is known for its high learning curve, and that is true. But to start your learning Kubernetes, you have to know the concepts. So the rest of this session will be about the concepts. And why I chose this picture, well, this is the picture of the Stelvio mountain, one of the highest Alps, and it is laying in Italy. 2 years ago, I never cycled a mountain, and I cycled this mountain actually twice on a day. And I did that for charity, and it was really a high learning curve. I'm from the Netherlands, and in the Netherlands, everything is flat. So that was the reason of the high learning curve. So for Kubernetes, no difference, high learning curve, but I'm going to tell you the concepts. And at the end of the session, my goal is that you have enough knowledge about Kubernetes so you can start using Kubernetes yourself, if you find it interesting, of course. So let's start with the pod. I already told you that a pod can contain one or more containers. A pod is actually the smallest unit that you deploy in Kubernetes. So it's also your scalable unit. So a pod can contain multiple containers, but most of the time you deploy one container. For example, my frontend and my backend, I would use 2 pods because then I'm only able to scale the pods separately. But sometimes you need a second container, actually more for a design pattern. It's called the sidecar. And this sidecar can be any helper container for the main container. For example, an Istio container, or Dapper now, the Microsoft project. Or a custom container that you have created that helps the main container with, for example, reading configuration, doing something with certificates, reading a queue, that kind of things. They are sharing this. A pod has only one IP address, and so you have to give a unique port to each container in the pod. So let's dive in, and then we go to a demo as well. I talked about YAML files. Here at the left, you can see such a YAML file. This is what we are going to deploy to execute to Kubernetes. This is a declarative file. And if you take a look at this file, you can see that it is a deployment. At the right, I have drawn the components that will be deployed to Kubernetes. So we can see the deployment here as well. It is really a component to Kubernetes as well. I have configured this deployment to run 3 replicas. A replica means an instance of a pod. So that's the reason why we get 3 pods with a container in it. And it is running this container, this image. This image can be found on my Azure Container Registry, which is a private registry. You can also see here that a replica set is being used. You can see that in the deployment. That's by default what you get. That's the way Kubernetes works. I will show you in a couple of minutes what the replica set is being used for. Also remarkable is that the deployment, replica set, and pods do not have any relationship with each other. There are no lines drawn. That is because of another concept in Kubernetes called labels. So a pod gets a label backend, and the replica set has a label selector backend. And that way the replica set is connected to this pod. You will see the labels several times during the session because it's an important concept in Kubernetes. So let's go to Visual Studio Code. All right, I have Visual Studio Code here. And I've installed kube control, the command line interface tool for Kubernetes. So I can execute this line with a single click, and I'm getting the nodes. So these are the worker nodes that I have provisioned in my cluster. I have 3 worker nodes, and the cluster is running for a pretty long time, more than 3 months. It's not the newest version, but at that time it was. You can also get the pods that are running. And we can see there are no resources found. So I have a completely clean Kubernetes cluster. Here in this directory, I have the same YAML as that you saw in the, this YAML is it. I have the same YAML as what I showed in the slide. So let's apply this YAML. And you can do that with the command line interface with apply, -f for file, and then the file name. So it is created. Let's see what we are getting here. We are looking at the pods again, and I'm giving an extra parameter, wide, so we get a little bit more information. And we are seeing that we indeed have 3 pods running now. So in a couple of seconds, I have 3 instances of my application running. I was telling you that containers are fast, that Kubernetes is fast as well. There are already 3 applications running, so that is nice. It is actually remarkable. We can see that each pod is running on one of the virtual machines, one of the worker nodes. Kubernetes decides on which worker node he is running. And most of the time, actually, he decides that each worker node gets 1 pod. But this time he has chosen to run all pods on one virtual machine. Well, okay. Well, if you don't like the command line interface, there are other ways to run this. And I will run this in another window because we need this. I'm starting a tunnel to the dashboard. You can do that with kubectl proxy. So with proxy, I now have a tunnel to a pod which is running in the cluster, and that pod is running the dashboard. The dashboard is also an example of what you get in the public cloud for free. It's installed already. But if you run it on your local machine, for example, you have to do something for that. Then you don't get it. All right, so the dashboard. This is the Kubernetes dashboard. At the left, you can see most of the concepts that we are going to talk about. And well, it has the deployment, which I was talking about. Let's click on it. You can see that it has the label selector for backend, and it has a replica set. Let's click this replica set, and there we can see the 3 pods. Well, great. One of the strengths of Kubernetes is the declarative form, and with that, I'm going to explain you what will happen when one of the applications is crashing. It's not easy to do that, so I'm just going to kill one of these containers. Just kill it. And as you can see, what is happening because of the declarative way of working, and the dashboard is not refreshing automatically, so I have to do it for him. So we have 3 pods running again. And based on the age, you can see that 2 pods are running 3 minutes, and this one is only running for 11 seconds. And this time it is running on a different virtual machine. So what happened? I killed the pod, and Kubernetes has started a new pod. And that is because I have told Kubernetes to run 3 replicas. I killed one, so only 2 were running. Kubernetes noticed this and says, oh, but I need to run 3 containers. So let's start another one. And he will do this all the time. So this is so powerful. This is the difference of being called out of bed in the middle of the night because of your production environment is down or not, because Kubernetes is arranging this for you. All right, next step, we can also scale. So let's scale this. I'm just going to change the number of replicas. So 5, and I'm saving the file and applying it again. Oh, but not in this window. That's the reason why I started a new window. And applying it again. Yes, it is applied, and I have to be fast because, oh, not this one. And there we have 5 containers running. Based on the age again, you can see that 2 pods are new. And now we have containers running on each virtual machine. So scaling, yeah, you can see this, the speed again. It is really fast. Okay, I just want to show you how my application looks like. This is the API, so that's all. So let's click on one of them. I need this name. And now I'm going to create a tunnel from my laptop to this container. So let's do that. I do that with kubectl port forward. And at this moment, I'm able to go to my application. I've implemented the Swagger interface, so we can just see it. There are a couple of APIs. Let's see the leaderboard here, try it out. And there we can see the data that it is returning. So the application is really working. And we can see some data here from Naber and Girl for some games, Far Cry, FIFA, 4 records. We will see this later on in the interface, in the user interface again. That's the reason why I show you this. All right. Let's stop this one. What would we do further? The next step would be provision a new version of the application. I was provisioning version 4.5.7. Let's go to the next step and provision 4.5.8. Kubernetes supports zero downtime deployment, and it's doing that with some configuration, of course. We can specify a rolling update strategy. That's what we do here. And we have specified that we have in the first case, we said you have 5 replicas, 5 containers, not less, not more. But now we are saying you may have 1 container more than the 5. And if that container, this is the new version, is running successfully for 5 seconds, then you are able to remove one of the old containers. Well, and if you were doing that for all 5 containers, then you have a rolling update, and at the end, you end up with your new version of your application. So let's apply this one. It is being done, and let's go to the user interface again. I have to refresh it several times, go to the pods, and now you can see that there are indeed more than 5 pods running. Based on the age, you can see that at this moment 3 containers, 3 pods actually are the old version, and the other one are the new. Only 2 left now, these 2, 7 minutes. And now all 5 containers are changed with the new version. So during this time, I had no downtime. Another big advantage of Kubernetes. And Kubernetes is supporting it, but you should support this in your application as well. So you have to do something for it. For example, your database, how are you going to migrate from the previous version to this new version? That you have to do that yourself, of course. But it is powerful that Kubernetes is supporting this. One thing to show you about the replica set. Because how is Kubernetes doing this? Well, actually, the deployment is the same, but it has created a new replica set. Now it has 2 replica sets. This one is the old one. It has no pods anymore. And this is the new one. It is running all 5 pods. And if you take a look at the new one, it has a revision of 2. The first one, of course, was revision 1. So now it's also very easy that if you make a mistake and you want to move back to the previous version, it's just 1 command line and Kubernetes is running the previous version again. So back to the slides. We talked about a lot of this already. We talked about the rolling update without any downtime. Then the next step, environment variables. Well, you should move your container from environment to environment if you are still using environments like development, test, and production. There are differences between each environment. So, for example, in this case, the log level is different. How can you do that? Well, just like Docker, with Docker, you use environment variables. In Kubernetes, it's no difference. So here you specify an environment variable, which can be different over environments. If you want to specify a secret, these files are in your Git repo, and you don't want any secrets in your Git repo. Well, there's another concept in Kubernetes called a secret, secret this time. In this case, it's a connection string to SQL Server, and the value is base64 encoded. And well, if you have a little bit of knowledge about encodings and encryption, this is not an encryption. This is just an encoding, and it is very easy to decode this. So it is called a secret, but actually it is no secret. But this is what Kubernetes is supporting. If you have created a secret, then the next step would be that you specify the environment variable, and then you can specify your secret. That's the way Kubernetes works. There are multiple kinds of secrets. For example, I've also specified a secret here, the image pool secret. I told you that Azure Container Registry is what I was using as my container registry. It was a private registry. So also Kubernetes has no access to this registry. So how can it pull the container to Kubernetes? Well, therefore it needs credentials. These are the credentials. And then you specify it. There are multiple ways, by the way, in Kubernetes, but also in AKS to get access to your container registry. But this is the standard way Kubernetes works to get your to get credentials for your repo. Maybe you can you already see this, but we are going to extend the configuration with each slide that I'm talking about. So we started very simple, then we added the rolling update strategy, and now we are going to talk about health checks. And there are multiple health checks in Kubernetes. The liveness probe and the readiness probe are the most used ones. There are more than this. And the liveness probe and the readiness probe can be configured on almost the same way, as you can see. What is this, the liveness probe? Well, those are very important and very powerful. So the idea is that you create another endpoint on your application. Most of the time, it's called /health. And you can create such an endpoint using libraries like AppMetrics, or in ASP.NET Core, for example, version 3, it's already built in. You can use that. This endpoint always returns a 200 when the application is healthy, and a different HTTP status code when it is not healthy. How do you decide what is healthy or not? Well, you decide it yourself. You can, for example, access your database, and if you can't access it, well, you return an error code. You can try to access other services that you are dependent on. You can check access rights, configuration, well, you name it, you decide what you check, and based on that, your application is healthy or not. Kubernetes is checking this health endpoint, and the threshold here is configured on 3. So when Kubernetes receives 3 times on a row a different value than 200, so when your application is not healthy, then it will restart your container, completely automatic. Another powerful feature that prevents you being called out of bed. There is also this readiness probe. Configuration is the same, but it has a different purpose. Sometimes your application needs time to start up. For example, it needs to read a queue, needs to read configuration, and that takes time. And during that time, actually your application is not ready to do something for the end user. So during that time, you don't want to have any traffic routed to your container. That is what the readiness probe is doing. So only when your application is ready, you get traffic. Another point of configuration. So the configuration will be very extensive. Resource management, and this is a best practice. You should do this always. What you are configuring is the resource requests and limits, which means what is minimum required for CPU and memory, and what are the limits for CPU and memory. Based on this configuration, Kubernetes decides on which worker node your application will be running. If you leave it out, you have the chance that you're killing your whole cluster because this pod can get all the resources that it wants. Another reason to do this is because of this, you can configure the scaling. There are multiple scaling possibilities in Kubernetes, and I'm going to explain you during this slide how it is working. So we can see the 3 workers here again, and we are going to scale the blue container. And we have configured the pod autoscaler. It scales from 4 to 20 containers. And it is only allowed to scale when the CPU usage is 60% or higher. So let's add some load on the blue container. And what will be happening? Well, Kubernetes will autoscale because that is what we have configured till 20 containers. Or, of course, the workers have limitations in CPU and memory, and there will be a moment when it is just full. And when that happens, well, he can't scale anymore. But you have options to solve this. You can also configure the cluster autoscaler. The cluster autoscaler, yeah, well, it can add a worker node automatically based on this. And, well, of course, the new worker will run the workloads also. And this way you can scale actually unlimited. So multiple ways of scaling. All right, that was the configuration for the pods. And I also showed you how you can access your application. Well, actually only as a developer, because I was creating a tunnel for my laptop to the pod. But of course, I want more. I want that my end users can access my pod. So let's see how we can do that. It's not easy because a pod has an IP address. And when a pod crashes, Kubernetes will make sure that the pod is running. So actually we need a fixed IP address, and that can be done using a service. There are multiple types of services, a cluster IP service like this one, or a load balancer service that is communicating with the cloud, and you get a public IP address. You can also see the labels here again. So what does this mean for our application? We have the front end and we have the back end. Each gets a service. It's not necessary for me that the backend is accessible through the internet. So a cluster IP service is enough, and the front end needs a load balancer service. So we have the IP address. And then the front end needs to be configured to access the service of the backend. And we can do that based on DNS names. So this is the configuration of the service. And here, this is the environment variable for the front end to access the backend. So just to show you this, I have prepared a demo in this cluster to show you this. And when I started this demo, I showed you there are no pods running. And now I'm telling you that I have a demo prepared. That's because I made use of another concept in Kubernetes called namespace. Till now, I was working in the default namespace, and that was empty. But I have created more namespaces, service demo in this case. You can see multiple pods here. And a namespace is actually a small virtual environment within Kubernetes. You can use it for several ways. One is for nice demos like this, but also to have, for example, a deployment per branch or multiple environments. You can see the services here, 2 services for the backend, only a cluster IP service, which is static, and the front-end service, a cluster IP and a public IP. And if I click on this, you can see my fancy front-end here. So this is the way you can make your application accessible through the internet. But the next step and last step here, what we're going to talk about is, yeah, but if I need, Kubernetes is very interesting to run your microservices. And if each service needs an IP address, then I will run out of IP addresses very fast, because you can only have like 20 or 25 IP addresses, for example, in Azure by default. Therefore, there is a concept in Kubernetes called Ingress. And to explain this pretty complex concept, in this slide, I've created 3 applications. 1, 2, 3. Each has 3 pods, and each has a service, just a cluster IP service. I also create 1 service with a public IP address, so it's type load balancer. And something special, one of the extensibility points of Kubernetes, an Ingress controller. This means that it is reading this configuration, the Ingress, and this configuration tells on which host name this service is accessible. The Ingress controller reads the Ingress configuration, creates, because I've chosen Nginx Ingress controller, is generating an Nginx configuration file, fully automated. And based on that, when traffic comes in, the Ingress controller decides to which service the traffic has to be routed. So this is how that works, Ingress. Well, that was the last concept which I was talking about, but actually it's only a tip of the iceberg. There are many, many more concepts, but this is a good start. You can already start using Kubernetes already with the knowledge of this concept. I do want to talk about one thing more, and that is the ecosystem. I told you that it is really big, and this is the CNCF Cloud Native landscape. And don't be overwhelmed. It's not the purpose that you read all this. It's just to give an indication how big it is, and not even all applications are on this slide. There is more. I've seen some Twitter posts from people with a screenshot of this, and they tell, well, Kubernetes is so complex, have a look at this. Well, that's not fair, because these components are helping you. And, it's the same as telling that .NET is complex and then showing an index of all the NuGet packages. That is not the same. Kubernetes is not easy, but it's not fair to say that Kubernetes is complex because of the ecosystem. All the big boxes are CNCF projects that I was talking about, like Kubernetes, like Helm, Prometheus, that kind of projects. I have to end my presentation, so I'm going to this slide. So hopefully you have a good overview of what the power of Kubernetes is. It's about auto-healing, about scalability, about reliability, and no downtime for your applications. So with that, with Docker, you can run your applications everywhere because it's so easy with a container, and Kubernetes makes it possible to run your container everywhere with enterprise features like scaling, updates, high availability, and all the things that I talked about. Well, thank you for your attention. You can find all the demos that I've given on this Git repo. Thank you for your time, and maybe talk to you later. I guess it's time for questions now, if there is time left.
Thank you so much, Pascal. Yes, there is time left for questions, and we've got a couple of them, actually. It was a very, very nice walkthrough. I really enjoyed it. let's take the questions. I also messaged you the questions in the Zoom chat because I think you need to read them. The first one is related to the principle of one microservice versus one Docker. And if you could read the question and then try to...
Yeah, I'm looking.
Great.
Let's see. I don't know how to get the... Is it somewhere here?
Yeah, so the question is, does the principle one microservice, one Docker KYS apply?
Yes. Yes, indeed. So a Docker container is a best practice to keep your Docker container as small as possible. That's Docker containers by itself are fast, but if you make it bigger and bigger, it will be slower. So keep Docker containers as small as possible. So if you are applying a microservice architecture, then it is the best practice to have one application, one microservice in one Docker container. Yeah.
And the question continues, what about alternatives as inter-services communication bus, like JSON bean serialization and so on? What about Redis, the message broker?
Well, Redis, let's see if I understand the question, because Redis is a kind of database where you can have key value stores, which are in memory, which is fast. So that is handy for your application. But it has actually not something to do with Kubernetes, I guess, or maybe I don't understand the question. If the question is, can I run Redis in Kubernetes? Then the answer is yes, you can, but you always have to watch out what you are hosting in Kubernetes. Until now, my advice is to not store state in Kubernetes. So if you have state, like what you store in the database, and doesn't matter if it's a SQL database or a Redis database, but keep that out of Kubernetes, because then you should have a lot of experience with Kubernetes if you want to do that. And that's because of the scaling, which is more complicated with still data, with data which is in the database. So keep your database out of it. I would use a platform as a service, a PaaS service in one of the clouds.
Okay, got it. Not sure if I conveyed the question very well. So possibly during the break, maybe we have a look together and then you kind of provide an answer and we publish it. It would be absolutely great.
Sure.
There's another question related to protobuf, Google's language, platform neutral for serializing data. There were on Git some custom messaging bus, quite well done, but with C#, smiley face.
Okay, what is the question?
I think we have to take it during the break, as I don't get it as well. There's another question. If you're using Docker in pod, then why not use Docker Swarm?
Yeah, Docker Swarm. Well, you can use that as well for your workloads. But yeah, Kubernetes is at the moment the de facto standard to run your container workloads. So most people in the field have experience. If they have experience with running Docker containers, then it will be Kubernetes. That is how a de facto standard works. It's a standard. You don't have to think about it, how you want to run your containers. Yeah, Docker Swarm, they just lost the war of container orchestrators. So, so you can use it, but I would not do it.
Okay, and yes, this will be the last question. When public traffic will hit on IP address, and how Ingress will know for which application this traffic is for?
Well, that is specified in the Ingress. So back to that slide. Oh, back to that slide. So based on in the Ingress, this is the configuration of the Ingress. you specify which host name. And this host name is specifying to which service it redirects. So the Ingress controller is just reading the host name and it knows which service belongs to it. If traffic comes in, he's reading which host name is being accessed and is routing the traffic to this service.
Okay, okay. There was another question related to auto-scaling, and we touched upon this topic. And I also remember that yesterday we had a talk about event-driven auto-scaling with Kida. Did you have the chance to...
Yeah, from Erwin. Yeah.
Yeah, exactly.
So yeah, that is one of the extensibility points of Kubernetes. So this is the default way that Kubernetes is supporting to scale your applications. Kida is using that extensibility point and is taking a look at how your application is behaving, and based on that is scaling your application. So it works actually the same and is very powerful. So if you're using Azure Functions, for example, like Aaron told you, then Kida is a really nice option.
Okay, Pascal, thank you so much for being with us at CodeCamp, and we're looking forward to the next edition, and hopefully you will be able to join us sometime soon in person, of course.
That would be nice. Thank you, and well, thank you all for joining my session. Speak to you later.
Thank you. Let's have a short break, 10 minutes break, and then we'll meet Darko from AWS.